Good day everyone, we are the group 9 and today we're going to discuss how to apply exception handling in GUI applications and how to manage input errors. Our hands-on demonstration is about extending a bank account GUI so that it supports deposit and withdraw features. We'll also show how to prevent invalid amounts using try-catch, just like in the reference video provided by our instructor. And our goal is to help you understand how exception handling improves the reliability and user experience of GUI applications. So what is exception handling? Exception handling is the process of responding to unexpected events or errors during program execution. In GUI applications, users often make mistakes such as typing instead of numbers, leaving input field blanks, or entering negative values. Instead of letting the program crash, we can use the try-catch to handle these errors gracefully and show clear messages to the users. Why it's important in GUI applications? Exception handling is especially important in GUI programs because 1. It prevents system crashes when invalid input is entered. It provides feedback to the users through friendly error messages. It keeps the program's logic safe. For example, the user shouldn't be able to withdraw more than their balance. So there are some common input errors we'll handle later. 1 is the empty or missing input, the non-numeric input, negative numbers, and number 4 is the withdrawal greater than the balance.
Here are GUI layouts and design. Let's take a look at our GUI design. The bank account windows includes first, a label that displays the current balance. Second, a total field for the amount. Then, 2 buttons, deposit and withdraw. And the last one, a label that shows status or error message. So when the users click deposit or withdraw, the program and the amount checks if it's valid and processes the transaction using exception handling. Next, here's the basic flows of our exception handling work and our GUI. So when deposit is clicked, try to read input, convert it to a number. So if amount less than 0, throw an error, else deposit and update balance. So if input is invalid, catch the error and show message. So the same logic applies to withdraw, but with an additional check for insufficient balance. So in this way, the program doesn't crash even if the user enters invalid data. It just displays the correct message. So here we are, simple code, Java Swing. Now here's an example of how we use try-catch in our code. First line, deposit button, add action listener, or block. So this means when the deposit button is clicked, do the stop inside the block. The second line is string text, amount, field, and get text. So this line gets the text from a box, probably when you type the amount of the amount of money to deposit. Third line is try. So this line, Java tries to run code here if something goes wrong, and it jumps to the appropriate catch block. So the next slide is double amount, double point parch, double text. So this line convert the text when you type into a number. Example, when 100 turns into a 100.0. So the next line is if amount less than 0. So this line, check if the number is 0 negative. If it is, throw an error. So the next line is amount deposit or amount. So this line adds the amount to your account balance. So the next is balance level and set text. This line update the screen to show your new balance. Then, so next line is status level set text. Close parenthesis, deposit is successful. So this is show a message that the deposit is worked. Then, the next line is catch illegal argument, exception, or X. Status label that set text, please enter a valid number. So this line, if the input was not a number. The next slide, catch illegal argument, exception, and status label point syntax, close parenthesis, X get message. So this line, if the amount was 0 or negative. And then, so last catch exception X, status label point syntax, close parenthesis, unexpected error, plus X dot get message. So this lines is any other error. So Notice that each possible error has its own catch block, so we can show a specific message for each type of error.
Now let us see how our program works in action. First, if we enter a valid amount and click deposit, the balance updates successfully. If we type a negative number or a zero, the program shows amount must be greater than zero. If we type text like ABC, it says please enter a valid number. For withdraw, if the amount is more than the balance, it says insufficient funds. These results prove that our exception handling is working correctly. To summarize, here are the key points from our discussion. First, exception handling prevents crashes and improves user experience. Second, using try-catch, we can control errors such as invalid numbers or negative amount. Third, proper validation ensures transactions are logical and safe. And lastly, clear feedback help user understands what went wrong. With exception handling, our program becomes more reliable, secure, and user-friendly.